Hello explorers and welcome to another video. Today we are going to talk about Vitess. And Vitess is a database management thingy that could actually handle multiple different databases as one or as multiple shards. So it's a way of scaling up your database infrastructure. And it's using MySQL, so you don't have to change anything. If you have written a lot of SQL statements and written a program against a MySQL database, you can scale it up using Vitess. But let's start with the history behind it. So, back in 2010, to solve the MySQL scalability challenge that the team at YouTube had, they come up with this solution. So, to summarize what happened, YouTube had a MySQL database that at peak traffic, it couldn't really serve the load. So, to temporarily alleviate the problem, they created a lot of read-only databases and then have one master database that I wrote to. And that served for a while, but with the demand of more and more cat videos at the high time, read-only traffic was still too high to overload the replica database, so YouTube added more replicas, again proving a temporary solution. So now they could write multiple of them, but they had a bunch of read-only. Eventually the write traffic became so high for the master database to handle, requiring YouTube to shard the database into multiple different shards to handle the incoming traffic. And as a aside, the sharding could also become necessary overall, for the size of the database became really large. And then the YouTube application layer was modified so it could execute any database operation, and the code could identify the right database or shard to receive the particular query. So that was the initial thing that went through at YouTube. And then 2012, they actually made it open source. So it's available on GitHub since then. And it has been in active development since 2012, which means that it's 10 years to this year. So it has been in development for a long time and it's well established. So it's a good thing to look into and try to figure out how it actually works. So let's jump over to my screen here. And here we have just a simple client, and I can log into my first node here, Vitess 3 I call that one. And here we want to start off by installing a bunch of things. So let's install some things here. We will have the default MySQL database server, the default MySQL database client, etcd and curl. So let's install those and talk a little bit about it. So this etc service is a configuration service where you can put multiple different configuration into, and there is a bunch of different services that you can use for the same thing, but the Vitess service is using this etc server to store information of where is all the other components in my system. And it's not required that you have that up and running all the time, but in order to find new servers and handle the changing of infrastructure, you need to have that service up and running. So you start it up, you connect a bunch of things to it, and those in turn confine each other. So that's what you are using the etc for. MySQL database is of course required because you will install a bunch of different MySQL servers in order to handle the traffic here. But for this example that I have here, I will actually take and stop the MySQL server, stop the etcd server, and disable MySQL and disable etcd. So I will remove those services so they are not started at least. They are installed but not started. Next up, we will fetch Vitess, and the current, as of this video, recent version is 13. They are in the works to release 14, but it's still in release candidate. I think it will be released sometime this month, So it's very soon it's going to be released. But we'll look into 13 right now. There is a bunch of new interesting changes in 14. There have been talks about not supporting MariaDB anymore. So that could be an issue if you're running MariaDB instead of MySQL. They are very similar, but there are still some commands that are different between them. So if you're just using a subset, it might work. Or if MariaDB has removed some functionality that is required for Vitess, that might be the issue. I will unpackage Vitess here. That will also take a little while, so I'll get back to you when that's done. So now that we have installed or unpacked Vitess, we will go into the directory of Vitess, and then I will create a directory in USR local Vitess, and then I will copy all of it over to that directory, so it will be in my USR directory and available to the system. This will take a while as it is quite a large application set. Next up, I need to put this into my path. So I will say that Vitess, the bin directory, should be in my path. I will go back to my home directory again. Next up, I need to set the port number of the web service, the VTC control D. So this is a control server that is not really a part of the actual system where you run all the traffic through. This is a worker daemon that can move data around and handle the day-to-day work, but it's not a part of the actual calling infrastructure. So if you say that I want to do this specific SQL statement, it will not go through this service. I also need a cell. I call that zone 1 in this case. And a cell is pretty much one part of the system, which could be a data center or similar. So it's just one part of where all data will be served, and it will try to fetch data from a close cell. So if you are trafficking the traffic through, it will not go to a different cell to fetch the data if it doesn't have to. And then we want to set the etcd control API to 2. We want to set the host name, and here I need to check what the host name is of this server. It's 55, so we change this up here. So I set the host name to my IP address. I need a data root, so this is the data storage place. So here it will store all the data. And then I will set the actual host name of with port of this etc server. So create a variable for that. And then I create a bunch of topological flags. And this is a way to say that I want to use the implementation etcd2, so that specific protocol, where the etcd server is and where the global root for this is. And the reason I set these flags is that all the things that I will start here, the different services, will use these flags to find this etc server in order to find each other. And at the moment, they will look for each other on the global root. We will create two different routes, one for the cell and one for the global. So if you want to shard it up with in different cells, you will say that topological flag should be the local cell, so they will not talk outside of that cell. But this is still just a proof of concept here. I will create two directories, one temp directory and one directory for etcd. And I will create some aliases here. One alias for MySQL. So this is just run MySQL for the local host and the specific port for localhost. In this case, 15306. So put that there. And then I will create two for the client of the VT control client and VTD control client. So these are two ports to connect to those. And I will expand these aliases so they will be available here. Now I want to start the etc service. So here is what I need to run for this. We will enable the second version here. So the second version of this protocol is the only one implemented for Vitess, so that's why we need to enable it there. I think that is default, so you don't need to have this flag, but being explicit is a good thing. We put the data there into our data root here. We listen to all URLs on the etc server URL here, HTTP. We advertise client URLs on that as well, same. And we will write out the log to the temp directory here if we want to check that later on. So if I check in vt data temp etc out, you see here that the service has started. And now I want to create the endpoints that we were talking about here. So this is the global endpoint that I can start here. So endpoints, the server make the directory of global. So that is what we will connect with our services in this topology, but we will create a cell as well. So that will be available here. And next up, we will run the specific Vitess client, and we will see here add cell information. So the information about the current cell. So we say that we are running this with the topo implementation of this, and then the address and the global root and add cell information. So here I could use this variable topological flags. That will be the same here. Add cell information to the root of this cell, and then I will have the specific address and then the cell name. So here it says that VTC should not only be used for VDEV workflow, and other things is deprecated at the moment. So consider using the other client for that. But it doesn't really matter. I have created this cell info. I tried to figure out how to do it with the actual VTD client, but I didn't get it to work. So this is the easiest way to set up those cell information. But you need the information in your etc control server in order to actually find all your things. Next up, we will start this service, this control daemon, with the topological flag, so other things could find it, the specific cell, and we will take this workflow manager and initialize it. We will use election in order to figure out which one should be the primary. We will have this service map, so grpcd C will be used in order to talk with each other. The storage implementation here for backups will be on files, and the backup storage root will be in backups. Logdir is the temp dir. Here we have the web port that we saw earlier, so we could actually find this on 15,000. And then we have a GRCP port, so it could talk to other things, and that is on that port. And the PID file for this, so we know that it's running. And also the out, so we can see that it's started okay. So if we cat vt root temp and this out file here, it doesn't really say anything. So let's see if it actually started. Grep btcl control D. Yeah, so it just didn't log anything out. So that's a good thing. Let's switch over to my browser here, and let's go to 55 and that. Then we can see here we have the application. We don't have any specific data. We can see that we have zone and global, and here we can find the cell information for this. So that's what we have set up so far, but we have a web GUI that we could look through things. Next up, we want to create our first MySQL daemon, and I actually created a little script for this. So let's create node sh, and I will put the script in here. So here, first up in the script, I will create 3 different ports. One for the tablet, and a tablet is pretty much a way to control one database engine. So each database engine that you start on a different port will have a tablet connected, and that tablet will handle all the migration information and also all the ingress information. So we will put that on a specific port here. So we'll have the first port and then add whatever I put in as the first argument. Same goes for the gRPC port, which they will talk over, the 16,000 and then what I put in. And then MySQL port is that plus whatever I put in. And so here we have the MySQL server. It will have the tablet ID of the first argument, and then MySQL port, and the temp directory will be our log directory, and we will initialize that service. Then we'll create a directory for this specific tablet, so VT, and the specific name of the tablet. We will use these topological flags here so it can actually be found in the network. We will create a logdir. We will have the queries to file, so it will actually create a query log, so we can read this log to see all the queries that have been sent to this tablet. We have a tablet path here, so this is a tablet path, so we can find it within our, if we look in the GUI and so on. So this is what will be saved in the etcd server as well. The host name, we haven't added that, so that will be fetched from the local host. And we will say table space is commerce. So this is not a key space as in whatever you say when you have these kind of object storages. Key space here is pretty much a database. So I say that I have a commerce database here, and this will create an VT commerce in each of the databases that are replicated for this commerce database. And currently I only have one shard of this. So you can shard your data, different parts of the tables and different part of the database could be in different locations, different shards. So you could have a different shard number here, but this is the first shard, 0. And then we have the tablet type. That is something that I will put in as the second argument here. So you could have read-only databases or things that could be primaries, different replicas. Health check will be done every 5 seconds. Enable semi-sync. So that is a specific mode of actually syncing data. So you can have none, you can have semi-sync, and there is a couple of others as well. So it's a way of telling the system how it should actually handle conflicts and so on. Enable replication reporter could be good. This is taken from one of the examples, so I haven't really looked into all these features yet. Backup storage implementation that we saw before, same here, file and where to put it. Restore from backups should be allowed. Then we put the port and gRPC port down here. So we can actually start on those, say which ports those should be. And the service map should be gRPC query service, tablet manager, and update stream. So these are the available things for this gRPC port to handle. And then we set the specific PID file for this service, how it should be running. And last but not least, the address of the control server, where that is available, and also our log file so we can actually see that it's running. So this was the script I created here. If we run create node, yeah, I need to make it runnable as well. Create node, and then we run create node 100, and this is a replica. So now it should be running through and creating this first tablet with a specific replica. If we go over here, it hasn't created anything yet here. But I think if we go over to this address, 100, it should be available here soon so we can actually get some statistics from it. It might take a while for it to start. So let's see if the file was created here. TMP. tablet, VT tablet out. Vitess log info. Unknown tablet type. Did I misspell it? Replica. Yeah, replica. So that's the name I should have there. So here it has started now. So now we can see it. So that was a little bit bad of me to mistype that one. So now we have created a replica. We can see that it's up and running. And we see here also that we have commerce and one shard. So of course, we want to have multiple of these. Well, why else would we do this? So we will create one more and we will do that read only. Put that in. And it takes a while for it to create it. There it's done. So if we go over here and take the same look here, we have another service running. If we now want to make one of them the actual primary, I will create a new primary for this commerce. So I will use the VT client, planned shared replica shard, commerce, shard 1, 0. And then the new primary for that should be zone 1, 100. So that first replica we created. And it will run through and create that to be our primary. So now the new primary is set. We want to add some extra information here. So I will use this to apply a schema file to this database. This is something that you can do within the database as well. But I will use this command to apply the schema to this commerce. And we also want to apply the V schema. And I'm not really sure what the V schema and schema is. I haven't looked into that yet. So this is still just a proof of concept here. And if we change this up, they change the actual name of things. So now I created that into this. Now we want an actual gate. And gate is, you have these tablets which can actually handle the traffic and information and look at things up in the database, but you need to route the traffic into those tablets, and the gate is what's doing that. So you create a bunch of different gates on different servers, and they can find which shards to look for things and which vtables should have the data. And they can also take a query and split it up in smaller parts, pick things from different shards, and then create the actual final result for you, which is also a really cool concept. So this gate here, we use the topological flag, so it will actually be found. We have a log directory, we have queries file, we have the port 1501, and then a gRCP port here, and then the MySQL server port that it should be found under. So if you're just using your MySQL command, you could go to this specific port and find it. That it was the alias that we created earlier. We have a socket path here, and then we have a cell and a cell to watch. So both of those is added, so we know where this gate is located in our larger structure. So if we have multiple data centers with the same database services, it should be trying to do calls to this local cell if possible. If the data is not available in this cell, of course, talk with the other ones, but try to fetch data from this cell. And tablet types to wait for is primaries and replicas. Service map is the gRPC vgate service should be available here. We have a PID file, and the MySQL auth server implementation we have none at the moment, so that is something you can implement later on. And then we have the log file here. Still, this is proof of concept thing, but I could type MySQL now. I should be able when this has actually started. So let's see if there is something to wait for here. Let's go to that address. So that should be a 1. Can we see the gate there? Now the gate has started. We can see that we have a primary and a read-only. You don't have any replica lag between them and so on. So they are available. Now I should be able to do the MySQL command here. Yeah. So now you see that we are running on the Vitess server here, version 13. The specific runner, we're using a specific version of Go, but this is MariaDB. If we show the databases here, we see that we have the commerce database. This is not the actual commerce database. We have a commerce database, a VT commerce database in the actual databases, but this is a virtual one pretty much. If we use commerce here, and show tables. So this was the schemas that we added. So we have a customer, we have products, and so on. So all that is added there. I want to again continue with this and add another server. So I've prepared a little bit here, things that take a long time to run. So actually installing Vitess and so on. I will export this path. I will do all the other exports and create directories and so on that we did earlier, pretty much. I will not create the etc service on this machine. It's not required. I will not set up a VT control, but I need to create more nodes. So let's do that. Let's create a node here. Let's add that script here. We change it to writable, and then I will create 200. This will also be a replica, spelled correctly this time. Let's wait for that to come up. It takes a little while for it to run. And then I will create a read-only database here also. So I have 2 databases running on this host. And I also want to set up a gateway on this server as well. Same parameters as the other one. So we will have the same port on this service as well. So this is Vitess 4. So this has the IP address of 56, if I'm not misremembering. Yeah, 56. So if we go, see here, the V-gate was closed. Did I put the wrong address? Yeah, the host name is wrong here. So I changed that up. Changed this up. Now I should be able to start the V-gate, right? Without it crashing. So it's actually finding. Here you see that we have done some queries already in this V-gate. This is the status of this tablet. So now it's up and running. And we can go over to 56. So we should find a V-gate there as well, whenever it has started. There it has started. So now we see the services here as well. Currently we only see the first 2 MySQL databases, but the polling for these databases is done every minute or every 5 minutes or so. So it can take a little while for the actual services to end up here before we actually see them. Now we see that we have the key space of primary here. We have done 3 queries to that on this. We still haven't seen anything and any more databases showing up here. We could do a PSAUX and see. So the tablet is running. It's not. So I guess that we had the same problem with the tablets here as well. Let's create a replica. And let's create that. Let's see if we get any tablets now. So now we have the tablets running, 2 of them. So the topo server is important. Now it will take a minute for them to show up here. So we actually get replication through both services. There we see. So now we have 2 replicas here and 1 read only. So did I say that 201 should be a replica too? Yeah, I did. Okay. It doesn't matter. So now 3 replicas, 1 read only. It's just a proof of concept where we see here that we have a bunch of different databases. We don't have any lag between them. Any of these replicas could become primary at any time. You can switch over who should be the primary. And the read-only is only there for queries that doesn't require any writes. So you could have more servers that could handle all the read loads. So if we go in here and we run MySQL here as well, we see that we can see the databases here as well. We can use commerce. So we see that we have that specific database here. We show the tables. We can describe customer. So this have a customer ID and an email. So let's insert into customer, into customer, values 1, hello, gmail.com. So now I've added that. If I select star from customer, so this was the second server, the version V2 that goes with V4, Vitess 4, which goes to Vitess 4's gateway. But if I go over to Vitess 3 and do the same thing here, select star from customer, it should see the same result, of course, because they are calling to different gateways, but the gateways has the same underlying data in their primary database or their sharded replicas. So I think this is a very interesting way of implementing things. It's very similar to Ceph when it comes to how it actually replicates data and how it handles all the different workflows. You have in Ceph different OSDs that is directly connected to the data, the derives. In this case, you have tablets that are directly connected to the tables or the databases in the database server, and the tablets or the OSDs could talk to each other in order to replicate and fix the database. Then you have this control server that could actually steer traffic and handle the actual migrations and also failovers and so on. This is the managers or the monitors in the system of Ceph, which does that kind of role. And here we have also the gateways, which is the monitors again in the Ceph environment, where all the traffic goes into the system and where you can figure out where the traffic should go. In this case, the actual gateways does a little bit more when it comes to the actual queries, because they could split the queries up, send the queries to different servers, and then gather the result. They can also do the actual sorting and so on for queries locally, so it will be a lot faster than actually doing it in the different cells. It could also handle when you are writing a query which doesn't have a limit. You can actually set limits and so on and fetch from different servers in order to speed up performance as well. So I think there is a lot of things here to learn, a lot of things to understand, but I still think it's a very cool and very well built technology that has been in development for 10 years. So there is a lot of things going on. I hope that you found this interesting. I'm hoping that you are as excited as I am. If you like this, give it a like, share it with your friends and colleagues. If you're using Vitess today, or if you are excited about this and have any comments or suggestions, leave them down in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.